Minglava. In the previous videos, we talked about the logistic regression classifiers, and we also discussed what are the common methods or classification machine learning methods for classification problem. Right. In these videos, we are going to talk about k-nearest neighbors classifier. K-nearest neighbor classifier is one of the I would say not mostly used, it's the easiest one, right? Easiest one to understand. One of the supervised machine learning method, which is very easy to understand. Okay. So the logic behind of k-nearest neighbor is if you are in the same group, you will do the same thing. That's the idea, right? If your neighbors belong to a category, you are also one of them. So that is the idea of k-nearest neighbors. So how do we work the k-nearest neighbors? All right. So imagine we have the new data point. Uh, we calculate the distance from this new data point to all existing data using our similarity measure. For example, Euclidean distance. Right. Then we will find the nearest k numbers. Okay, nearest k number. Let's say if we want to find the three nearest neighbor, then we will find the nearest three neighbors, which are the closest to the new data point. Then identify and check whether this neighbor, what is the class that these neighbors belong to, right? So we will check the class that these neighbors belong to. Then we will categorize this new data into the class that belongs to the more neighbors. Right? This is how the KNN works. Now let's look at an example. This figure is downloaded from Google. All right. So look at this figure. Okay. Red star indicate the class A, and then green triangle belongs to class B. All right. Then we have this new data point, which is the yellow square box, and we want to see which class this yellow box belongs to, either class A or class B. All right. So now let's start with three nearest neighbor approach. Okay. So if you want to see the three nearest neighbor approach, all right, you can see the inner circle, okay, innermost circle, right? So if you look at innermost circles, there are two green and then one red color, right? So yellow has two neighbors from the class B and one neighbor from class A. Since there are more neighbors from class B, this yellow box will be considered as a class B. Okay. So now let's look at the five neighbors approach. All right, five nearest neighbor. So if you take the five nearest neighbor, okay, if you take the five nearest neighbor, there are three green balls, three green triangles closest to the yellow balls, and then two red star close to the new data. All right. So three from the class B, two from class A. So this yellow bar will be still belong to class B. But if you look at the seven nearest neighbors, right, you have to see the outer circles. Okay, if you look at the outer circles, out of seven neighbors that this yellow box has, three are from class B and four are from class A. So this point will be considered as a class A neighbors. Class A, right? This one belong to class A. So obviously you can see that the number of neighbors k is pretty important. All right. To choose the optimum values of k is a very important, and at the same time is a difficult task. If you choose a smaller k, it will overfit. Right? It will work well for your training data, but it will not work well for the new testing data. If you take the larger case, it will ignore the local particularities. All right. So it will end up fit and it may not perform well for both training and testing data. Okay. Let's try to demonstrate with one examples. All right. Let's imagine in this class, most of you are non-smokers. I know, right? Most of you are non-smoker. So now we have a new student join this class. I want to see if this student smokes or not. All right. So I don't know yet. So what I'm going to do is I will take it her best friends, okay, her nearest neighbor, her best friend. All right. So when I see that her best friend, okay, her best friend is a smoker, I will consider this person as a smoker, new student as a smoker. All right. So I set k as a 1. So By doing this, it's lost the generality. All right, it lost the generality. Okay, so when we increase the k values, all right, when we increase the k value, the algorithm can be more generalized. Okay, can be more generalized because in general your class is majorities are non-smoker, right? So in this situation, if I increase the k to be as large as your number of students in this class, I will always get as a non-smoker because majorities are non-smoker, right? So once the k is very large, also sometimes it lose the loop group, the properties inside the small group subgroup. That's why we need to choose the proper key, right? How one can do is, one way is doing the trial errors. Setting the allow keys, all right? Then we will choose the, see the performance from the training and testing, and we see the best record, right? Best number. Or sometimes we can use the K by the looking at the number of data in your data sets. One of the common method used is a elbow method. Okay. How does the elbow method work? All right. This, we use a validation test to check the error. All right. So once k values increase, initially once the k increase, the error decreases. But at one particular point, once the k increase, the error will be going up again, right? So at the elbow point, okay, minimum point, we have to identify the k. For this example, k should be set as 10. This is how optimal k can be used. Optimal kb can be found, all right? And then we use this k to train the algorithm. So, like the logistic regression, KNN can be implemented using the sklearn library. Okay, we use the sklearn neighbors package and then import the k-neighbors classifier. Right. Then you have to define the number of neighbor. In this example, I define the k to be 3. Okay, so I set and neighbor to be 3, and use a fit to train the model and score to compute the accuracy. Similar to logistic regression, we can use the confusion matrix and classification report from the sklearn metric package to compute the to measure the performance, to evaluate the performance of your KNN classifiers. Okay. For this example, this is a result that we have. All right, we have KNN classifier has correctly classified 106 positive cases and 59 negative cases. Okay. So we can see the accuracy is a bit lower compared to the logistic regression. The performance of this KNN classifier definitely can be improved by tuning the hyperparameters K and distance measurements. So the KNN is very simple and easy to understand. And then when you use the SKL, also it is sklearn, it is also easy to implement. All right. So we should try using the different parameter K and then see how does the performance go. Okay. Thank you very much. That's all about the KNN classifiers that I want to cover in this class. In next videos, we are going to talk about the supervised machine, which is one of the most popular supervised learning method for classification problems. Thank you. See you all in the next video.